Good evening, everyone, and welcome to this very special online forum. Collision Course, 3 Degrees of Global Warming and Humanity's Future, brought to you by Breakthrough, the National Centre for Climate Restoration. My name is Emily Rice and I'm delighted to be your host for this really important discussion this evening. Before we get underway, could we please take a moment to acknowledge the traditional owners and custodians of the land on which we meet, and also recognise their continuing connection to country. We pay our respects to elders past, present and emerging, and also any Aboriginal and Torres Strait Islander peoples joining us. Tonight, we're here to confront the urgent implications of climate change. And our focus, of course, is exploring the key findings in Collision Course, which is Breakthrough's latest report. Now, if you haven't read that report yet, you can at any stage. It's at breakthroughonline.org.au, and it is a very, very sobering but a fantastic read. For those of you not overtly familiar with Breakthrough's work, Breakthrough, the Centre for Climate Restoration, is an Australian-based think tank. The team there have been working for more than a decade to redefine how we think about climate risk. Its research reveals the inadequacy of current pathways and mainstream projections and highlights that business as usual is a direct route to climate catastrophe. Shortly, we will unpack the stark trajectory of 3 degrees of global warming, offering a clear-eyed examination of the profound risks to humanity, ecosystems, and the foundations of global stability. It's not going to be a one-way conversation. We do have a presentation shortly, but also we invite you to ask questions after that presentation. Pretty straightforward. Just put your questions in the Q&A box. Please keep them clear and succinct and add your name or a pseudonym or just your first name so we don't have a whole list of anonymous questions, please. So just how close are we to 3 degrees of global warming? And what are the tipping points that we need to avoid? And more critically, what actions can still be taken to avoid this alarming trajectory? Well, here to answer those questions and many more, please welcome David Spratt. He's the Research Director at Breakthrough.
Thanks very much, Emily. As Emily said, recently Breakthrough published a report called Collision Course, 3 Degrees of Warming and Humanity's Future. It provides 10 key points of one sentence each, drawn from the recent research and observations of the climate system, emissions path and projected impacts. In this webinar, I will go through those 10 points and then talk a little bit after that on politics and policy implications. So I will share my screen. I want to start with the issue of hope or fear. So I think what's important here is that if we look at public health education, for example, the campaigns on smoking or AIDS or pandemics, there's a clear pattern in all those campaigns. The first is to be really honest about the problem, whether it's the Grim Reaper, whether it's the pictures on the cigarette packets or whatever. There is a clear statement of the problem. There is hope. There is a solution. You can stop smoking and your lungs will get better. And there's a pathway. You can join the quit line. You can get a vaccination, whatever. But this is the clear path in public health education: fear, path, hope, and solution. And so. I've really been drawn to this quote from Octavia Butler, the American writer, who said, "The very act of trying to look ahead and to discern possibilities and offer warnings is in itself an act of hope." And together with John Schellenhuber, the leading climate scientist in Europe, who says political reality must be grounded in physical reality or it's completely useless. So I hope that these 10 points are going to make us grounded in the physical reality, and they offer both a warning and a hope. So the point one is that 1.5 is here and now. Global warming was 1.5 degrees in 2023, which shocked scientists. Some of them thought it wouldn't happen for another 5, 10 or 10 years. It was certainly ahead of the projections. They thought 2024 may not be as hot because the El Nino was fading, and then 2024 was 1.6, which was a bigger shock. And then January last month was 1.75. So this is of deep concern because what's now clear as the great American scientist Jim Hansen said in the paper released 2 days ago, global temperature averaged over the El Nino-La Nina cycle, going through that cycle, has already reached the 1.5 degree threshold. And we know from the work of his and others that the rate of warming has accelerated. So let me just illustrate that. This is temperatures over the last 140 years. The red line is the sort of 10-year moving average. And if you have a look, you can see that this green line, this green dotted line, has been the best fit from 1970 to 2010. But if you look at the last 15 years, the purple line, you can see this sharp acceleration. So warming's actually gone up from about 0.2 a decade to 0.3. And so scientists, for example, Catherine Hayhoe from the Nature Conservancy in the US says, this is happening at a much faster rate than ever documented in the past. If anything, we are much more likely to underestimate the impact of those changes on human society than to overestimate them. The second point in collision course was that this is happening faster than forecast, and climate extremes are hitting hard. I think we've seen that around the world. The LA fires, the hurricanes last year, the evidence is everywhere. Many impacts are occurring faster than forecast by scientists in the models, including the severity of extreme events. And I think this is a really interesting point, that we say, oh, look, warming will go up an average of 2 degrees, but it's not the average, it's the extremes that matter. As we know, it's not the summer that's necessarily dangerous, it's the hot days. And so some scientists at the University of New South Wales said to me once, if global warming is 2 degrees on average, then it's 3 degrees over land. It's 4 or 5 degrees in the regions that are drying, which is most of Australia, because we're a dry continent. It will be 5 to 6 degrees in summer averages in dry regions, and 6 to 8 degrees hotter for individual days during heat waves. So 2 degrees global warming on average can mean individual hot days of 8 degrees or more. And that's why in the next 20 years, perhaps most of Australia will be vulnerable to warming of 50 degrees or more. This iconic photo from Valencia last year, those incredible Spanish floods, I think sums it all up. But just in the last year, we saw Death Valley, 54.5 degrees, the incredible heat wave in India, 1,300 pilgrims dying in the Hajj in Saudi Arabia, where the temperature almost reached 52 degrees. The record-breaking rainfall in Central and Western Europe, which cost billions. The devastating floods in Brazil and Kenya. And just before Christmas, a cyclone that wasn't that well reported in the French colony of Mayotte that destroyed 35,000 houses. So these are the sort of extremes that we're seeing. And it led Johan Rockström, perhaps today the leading climate voice in Europe, to say the planet is changing faster than expected, hitting harder on people across the world. We must admit we have underestimated the risks. That's the important. We have underestimated the risks. And so Sarah Perkins Kirkpatrick from ANU, we are hitting record-breaking temperatures much sooner than I expected. The third point is that system tipping points are tumbling. That is, that there is now clear evidence that a number of system-level tipping points, that is, when a major part of the climate system changes rapidly from one state to another, from there being ice at a pole to not being ice at a pole, and it's happening much quicker than projected. We have the work saying that 7 of the 9 sustainable planetary boundaries have already been exceeded. And it's clear if we look at the extremes, if we look at the heat, we look at these tipping points, and I'll show a picture next. Climate change is already dangerous. This is a really strategic point. It is already dangerous. And the current level of CO2 in the atmosphere, carbon dioxide in the atmosphere, is too high for a safe climate. And we'll come back to them. So if we look around the world, I'm sure most of you have seen this map before, some of the big tipping points. And there's 4 of them: coral reefs, Arctic sea ice, the ice sheet on Greenland, and the ice sheet on West Antarctica, where those systems have clearly passed their tipping points. That is, you don't need to put any more heat in the atmosphere or any more carbon dioxide in the atmosphere for these systems to change to a completely different discrete state. It has already happened. Then there are another three where there are large carbon stores, the permafrost, the boreal forests, and the Amazon rainforest, where there's now compelling evidence that they are becoming net sources of carbon. That is, rather than storing more carbon for various reasons to do with heat, increasing fires and melting, they actually become net sources of carbon. And of course, the big climate story, which I'm sure you've all heard about in the last year, the Atlantic circulation, called the AMOC, the Atlantic Meridional Overturning Circulation of sometimes colloquially the Gulf Stream, and whether that, which has already slowed, might actually stop. And there's projections at the moment that that may dramatically slow in the middle of this century, 20, 30, 40 years' time. And that system, in the important part is that the surface warming picks up heat from the Caribbean and takes it up along the American coast and particularly into northwestern Europe. And it makes it several degrees warmer than it otherwise would be. If, and as I said, the current experts who are really, I mean, beyond disturbed, despairing at the research, says if that system should shut down, slow, then agriculture in the UK, Ireland, and northwestern Europe would effectively be non-viable, in the words of one scientist. The West African and South Asian monsoons would become unreliable. There'd be a 1 metre sea level rise on both sides of the Atlantic. Australia would become warmer with more flooding, and there would be a flip of the wet and dry seasons in the Amazon. Point 4, and we don't want to say this, the world has not decarbonised. And by that I mean annual emissions of human-caused greenhouse gases continue to increase. They have not yet plateaued. They should have a long time ago. We hope it's tomorrow. We hope it's next year. But they have not. And the reason is that in absolute terms, decarbonisation has not occurred because lower emissions from renewables are being offset by growth in other areas of fossil fuel use. And we'll see that for Australia in a moment. So on current trends, it's likely only to be a slow decline in emissions to 2050. This is from the Australia Institute. If you look at the bottom chart, this is electricity emissions. And you can see from 2005, they went up, then came down under the Gillard government, the carbon tax went up. But now, because of renewables, have decreased a lot by 40 megatons of carbon dioxide a year. But all the other emissions from transport, stationary, fugitive, industrial emissions, like fugitive emissions from coal and gas, are actually going up. And these balance each other out. So reduced emissions from renewables are being matched, unfortunately, by increased emissions from other parts of the economy. And so the projections from the United Nations Environment Programme is that by 2050, this is the current government plans and projections, is it actually won't be much lower than it is now. It's what's called the production gap. Obviously, government policies need to be a lot stronger and go way down, but that's the current reality. A great example is the United States, which we seem to talk about a lot at the moment. US crude oil production in the last 18 years has more than tripled. More than tripled. The US is now the world's largest oil exporter and plans to more than double gas exports. In fact, it's the largest producer of fossil fuels in the world. Exported gas is actually worse for emissions than coal. And one analyst says that US demand for electricity will climb by 16% in the next 5 years, much more than they expected. And that's because big tech and what is happening with crypto, with the cloud, and particularly with AI, is it consumes huge amounts of electricity. And that boom is actually driving up electricity demand, which at the moment is at a rate faster than renewables can deal with. The fifth point, and we've seen this everywhere, that the petrostates and big oil are on the offensive. I mean, we've just had petrostates host the last two COPs in 2023 and 2024. And contrary to their policymakers' intent, big oil and big oil states have signaled their intention to abandon their commitments and continue to expand production. So that once again, from the UN, while we can see coal production going down, the intention of big oil is for both oil and gas production to increase to 2050. And whereas, for example, at Paris in 2015, they were saying in words at least commitment to net zero 2050, and they're now abandoning those commitments, as are big banks who over the last month have been pulling out of various international climate emission reduction commitments. So we have the CEO of Saudi Aramco saying we should abandon the fantasy of phasing out oil and gas and instead invest in them adequately. Our very own Woodside CEO, we should reject simplistic notions about the transition that can happen at an unrealistic pace, which they mean at all. And Shell, it's perilous to set targets because of uncertainty. It's like saying, might as well drive over the bridge because I'm not certain that it hasn't crashed. Point 6, warming is accelerating towards 3 degrees or more. What we've seen about the failure to bend down the emissions curve and the intentions of big oil and big oil states to expand production means that we are on a path to 3 degrees of warming. So the prestigious journal Nature surveyed a whole of IPCC scientific researchers and authors and said, how hot do you think it will get? And you can see that almost 50% said 3 degrees and more than another 10% said more than 3. So 6% said 3 degree or more. And towards the end of last year, Jim Skier, who is the chair of the IPCC, a relatively conservative body, said, we are potentially headed towards 3 degrees of warming by 2100 if we carry on as we are. What are the drivers of of us heading towards 3 degrees? The first, which we talked about, is the continuing high emissions, which are projected to decline only slowly. The second one, and this is really important and slightly complicated, is that in burning fossil fuels have sulfur in them, and when that sulfur is burnt, it goes into the atmosphere. They're called sulfate emissions, and they have a very strong short-term cooling effect. They also cause acid rain, that is sulfuric acid. And so in burning fossil fuels, we're also producing short-term cooling because of those sulfates. But now there have been large drives to reduce sulfates in fossil fuels. I mean, in China, for example, and particularly the International Maritime Organization, because bunker fuel is very high in sulfur. And that reduced amount of sulfates in the atmosphere over the last few years seems to be one of the main drivers of the acceleration in warming. And some research which just came out in the last few months has found that there have been in the last little period less low clouds in the atmosphere, and low clouds reflect solar radiation back out, so they provide some cooling, and that cloud formation is in part due to sulfate. So less sulfates, less low clouds, more warming. And of course, as I mentioned above, the carbon stores, like in the Amazon and the permafrost, are becoming less stable. And there's also some evidence that the capacity of the ocean to draw down heat, because the ocean at the moment draws down 90% of the heat that's generated by greenhouse gases, may become less efficient. The seventh point is that the physical risks are cascading and systemic. What do we mean by that? Systemic means that they apply to the system as a whole, and they're not adequately represented in climate models. Let me give you an example by going back to this pitch we talked about various tipping points. And we know that climate change is driving Arctic warming at 4 times the global average. And that warming of the Arctic is melting Greenland, and Greenland is pouring cold, fresh water into the North Atlantic. That cold, fresh water is slowing down the AMOC, the Atlantic circulation. That slowdown of the circulation will lead to high sea levels, a disturbance of the West African monsoon. That slowing of the AMOC is also leading to less rain and drying and fires in the eastern Amazon, which of course produces more smoke and carbon dioxide and emissions to the atmosphere. So the burning of the Amazon produces more greenhouse gases That produces more warming. The Arctic melts faster. So these are the tipping points, the cascading nature of the impacts, and the positive feedback. So the big sort of, I guess, the big scenario, and this was put forward by the great Australian scientist Will Steffen, who's unfortunately no longer with us. And they said, looking at past climates, there is a thing called a hothouse scenario where those self-reinforcing feedbacks, which we just saw in the previous diagram, and their interaction can drive the Earth system to a point of no return. That is, even if humans stop their emissions, these positive feedbacks will keep on making the Earth hotter and hotter and prevent temperature stabilization. And they said this threshold could exist at 2 degrees or even in the 1.5 to 2 degree range. And we're obviously at 1.5 now. So they've said it, and I think it's really a critical part of the strategy. Cooling the planet is an urgent priority. Point 8, this is our third last one. We have to focus on the plausible worst case scenarios. In the IPCC reports, they talk about a 50% chance of this. Okay, we've got so many emissions left for a carbon budget of 2 degrees with a 50% chance of failure. But that carbon budget with a 50% chance of 2 degrees has a 10% chance of 4 degrees, which will be civilization ending. So this is not taking the plausible worst case risk into account, particularly since the risks are existential, human civilization threatening, and emerging faster than forecast, and they're difficult to project. So we need to pay attention to the plausible worst case scenario. So I'm going to give a very local example. It's not the biggest on Earth, but it's interesting because in Melbourne, where I live, there's an old industrial area close to the city called Fisherman's Bend. Which is up for redevelopment. Here's a nice picture of it, courtesy of the University of Melbourne, and the state government says this is going to be a large urban renewal project, 80,000 residents, 80,000 jobs, new universities, all sorts of beautiful things. And this is what it looks like. Now, it's right next to the bay, and I'm told from sources within infrastructure Victoria and Australia that no sea level rise assessment was made of this site. And it is clear that by the end of this century, we could have a two meter sea level rise. Jim Hansen said he would bet $1,000 to a donut that it would be closer to 5 meters than 1. And the US government agencies have a 2 meter scenario. So a 2 meter sea level rise plus a storm surge with westerly winds of 1 degree is a feasible scenario. And if you apply that to this site, this is what Fisherman's Bend and part of Melbourne will look like towards the end of the century. And this is a classic example of risk assessment, high-end scenarios not being taken into account. Here's Fisherman's Bend. Here are the docks. Here's the casino. And this is the edge of the CBD, Flinders Street. I mean, it is absurd that we're not looking at these things. So Tim Lenton, who's done a lot of work on tipping points, says this is a planetary emergency. The risk and the situation is acute. If damaging tipping cascades can occur, this is an existential risk to civilization. Second last point, we're heading towards a world beyond human experience. That is, with extremes of rainfall and heat and flooding that humans have never experienced before. We know in the long term, you get 10 meters plus of sea level rise for each 1 degree of warming, and that large parts of the tropics will suffer near unlivable heat. So let me just show you that. This was work that came out a few years ago. The paper is called Quantifying the Human Cost of Global Warming. And the dark red area is an area they projected of heat, which they called near unlivable conditions at 2.7 degrees of warming, which will probably be at in 40 years. And near unlivable heat was those parts of the world that will exhibit heat never before experienced by humans. Mean average, they suffer between the hottest and coolest of the day of 29, resulting in near unlivable conditions currently found on only 0.8 of 1% of the planet's surface, mainly in the Sahara. So that's where we'll be at 40s. These parts of the world will be unlivable. And in fact, last week a paper came out saying another half a degree from here, from 1.5 to 2, an area of the United States will become too hot for even healthy young humans at 2 degrees. So just think about what that means for our region. I'll come back to Australia. This is Pakistan. This is India. It's Myanmar, it's Thailand, it's Malaysia, it's the Philippines, it's New Guinea. I mean, these areas could be unlivable, is almost beyond imagination. We're working and living, including outdoors, including agriculture without active cooling, that is, attracted with air conditioning, would not be feasible, and large-scale depopulation would be inevitable. And here it is, some work that was done with security leaders, and it's sort of odd that we're spending all this AUKUS money building and upgrading bases in the part of Australia where it'll be too hot to live in 40 years' time. Great defence strategy. This was some work which was published 2 weeks ago, and it looks at if the Atlantic circulation collapses, we have 2.5 degrees of warming, what will happen to the suitability of land for wheat production? Purple means less. Deep purple means 100% less. And just look at across Europe, China, India, Australia. I mean, that is just catastrophic for wheat production. Rice, not so bad, but not real good. Chatham House, the Foreign Affairs Intelligence and Defence think tank in the UK 4 years ago said if there isn't a sharp decline in emissions before 2030, then around mid-century we can expect a 30% drop in crop yields. Food demand will be 50% higher. There's a non sequitur, those two. And that 1/3 of cropland will be affected by severe drought each year, so that the cascading climate impacts will drive political instability and fuel regional and international conflict. And I think that's fairly obvious with that sort of food crisis. And in fact, there's a report from a conservative mob, the UK actuaries, just over Christmas, saying if we get to 3 degrees, they think GDP could drop by half and human mortality could be half of the human population, which I think is too extreme. But if UK actuaries are saying that, it should be taken seriously. So we are on the road to climate ruin. We are facing the potential collapse of natural systems, food and water crises, heat, that will simply cause an avalanche of social unrest and geopolitical conflict. So let me just finish with quotes from 3 scientists, Gerald Gerges from the ANU. It is extraordinary to realise that we're witnessing the great unravelling, the beginning of the end of things. I honestly thought I'd never live to see the start of what sometimes feels like the apocalypse. Sir David King, the former UK chief scientist, on our current path, civilization as we know it will disappear. If we meet current commitments, perhaps some form of humanity will survive. And Schellenhuber from Germany, who advised Merkel in the EU and many others, on the present path, there's a very big risk that we would end our civilization. The human species will survive somehow, but we will destroy almost everything we have built up over the last 2,000 years. So that, unfortunately, is where we are heading. And we have to, I think, face that brutally and head on, as Olivia said. So now to the politics. I was taken by this tweet from Joe Biden in September last year. On my watch, we've responsibly increased oil production to meet our immediate needs without delaying or deferring our transition to clean energy. We're America. We can do both, indeed. Or Starmer, the underperforming British Prime Minister. I will not sacrifice great British industry. I didn't know there was any British industry left. I will not sacrifice great British industry to the drum bang, finger waving net zero extremists. So let me just finish with a couple of comments. Obviously, this is the greatest risk to human civilization, though AI might be coming a close second, and it has to be the primary concern of politics and economics and of political parties and politicians. Climate is the biggest threat, and we have to take the science seriously. There are clearly 3 things we need to do. The first is to recognise that there's a danger in acting too late. We're at 1.5 degrees. We're going to charge past 2 and on the way to 3. There's no carbon budget for 1.5. There's no carbon budget for 2 degrees either. So the first lever is zero emissions fast in a decade, not 2050, because it is already too hot. There is already too much carbon dioxide in the atmosphere. The current settings are already civilizational threatening. For example, a few years ago, researchers in the University of New South Wales said, and I'll quote this, at an equilibrium climate under current temperatures would have a sea level rise of 5 to 10 meters. An equilibrium climate under current CO2 concentrations would have a sea level rise of 5 to 25 meters higher. So it is too hot. The current conditions will drown most of the world's cities. So simply eliminating fossil fuels, I shouldn't say simply, eliminating fossil fuels is not enough. The current level of CO2 is approaching 430 parts per million, and it needs to be under 320. So we need carbon drawdown, large-scale carbon drawdown to take us back to a place where humanity can survive with sea levels not too far away from the current level. The third point is that tipping points, as we've seen above, have already been passed or are approaching, and major systems are already destabilizing. So we need interventions now: short-term cooling, marine cloud brightening, increasing planetary reflectivity, whatever can be done safely to prevent the hothouse Earth scenario. That is, climate interventions and cooling are the third lever. So the important step now is the research, to step up the research to see if such interventions can be efficacious and of net social and environmental benefit. And of course, adaptation is important and necessary, but we must be wary that if we only adapt, as Catherine Hayhoe, who I quoted at the beginning of the talk, said, we can't adapt a way out of this climate crisis. So there I will end the PowerPoint and just make a couple of other comments about policy and where we're going. I think the big issue to me is that policy and policymakers have consistently relied on markets to try and solve the problem. But markets are very poor at responding to existential risks. Think nuclear, chemical weapons, pandemics, threat of AI, big tech. The threats, the risks are too big for markets to handle. These risks, as we said, are systematic. They're risks to the society as a whole and way beyond individual markets and their interactions. This is what actuaries call the risk of ruin in cards or wipeout. The big problem is the risk cannot be quantified. That is, you cannot put numbers to them because the damage is actually infinite and deeply uncertain. So the risk management mechanisms which are key to markets and to the global economy, cost-benefit analysis, risk analysis, simply don't work because there are no numbers you can plug in to get to a result. That is, markets are structured to fail on climate risks which are existential in character. And with any emergency or overwhelming threat, the only institution with the agency, the capacity, the power to act at emergency speed is the state. That is, as we see with other existential risks like natural disasters, wars and conflicts and pandemic, is the state that has a primary responsibility. The state mobilizes and leads and coordinates. Climate is no different. This, in the end, and you see what's happening with Trump and all these market deregulation people in the US, this is a political battle about the role and need for the state to tame the market's profound structural incapacity. The last point, very briefly, is disruption is inevitable and necessary. Paul Gilding wrote about this 13, 14 years ago. Markets and capital hate disruption because risk calculus fails in periods of high uncertainty. Take the global financial crisis. Markets break down. None of the risk assessments work, for example. So big finance, big oil, big polluting states have decided to go for short-term normalcy, continuity, no disruption, like drill baby drill, even though that path ensures social collapse. That's how markets and the government subservient to neoliberalism operate. The market first and the horizon short term. The problem is that disruption is inevitable because either, as we've seen in this presentation, we follow the market first path and their system collapse as outlined, or we act radically outside this paradigm such that the state becomes the instigator and organizer of a fast transition. There's no third way. Writing in 2021, the political economist Mark Blythe wrote in The Guardian, quote, "There is no mean, there is no average, there is no return to normal. It's only one-way traffic in the unknown." And I think that's really true. This idea that we can return to normal is simply delusional. So, and I'll finish on this point. The failure of the elites to countenance disruption as necessary makes disruption a necessary political tool. Thanks, Emily.
Well, thank you, David. A pretty sobering account of our climate reality, but thank you towards the end for bringing us back and highlighting those critical steps, those three critical steps. And there's obviously a lot more detail in the report. The report, for those people who haven't read it, does go into a great more detail with those 10 points that David has touched on. But now it's time to hear from you, our audience. Thank you for those people who've already put questions in. Please keep them coming. And of course, it's your chance to engage directly with David on these issues. So there are quite a few questions. Some are along the same lines. So what I might do to start is Judith, Jenny and Lena have asked a very similar question. And it's around the politics, of course. Essentially, Judith asks, why are our governments so blind and deaf to this? And Jenny wants to know how we can get candidates in the coming federal election to prioritise climate action. I think it's pretty much the same question. And then Lena talks about a briefing. So let's just focus for now, David, on why do you think governments are blind to this? And is there a way that we, and I think we mean the audience as well, not just yourself as a researcher, get candidates in the upcoming federal election to prioritise climate action?
Well, I know a lot of people are doing a lot of things. I mean, we've seen the teal movement over the last 4 years is a really good example of communities coming together and saying climate is a really big issue for us, and we're going to put a candidate in who makes climate their number one priority. So I think we have a model for that. And I mean, and that has been fantastic, working off the work that was done in Indi over the last decade of showing that independent candidates who really consult and talk and supported by their communities can do it. And commentators like Cos Samaras have been talking about the decline of the two-party system. I mean, we had the major parties in a by-election in Victoria last Saturday in Werribee, where the two major parties got less than 30% each. I mean, that's a great thing, because they're both the problem. They're both blind, they're both deaf in different ways. So I think that's encouraging in many ways. That, I mean, honestly, there are now more people who are prepared, not a majority yet. There are a lot more people in the federal parliament amongst the Teals and the Greens and Pocock and so on who are prepared to call a spade on climate than there were 10 years ago, when Bob Brown was in the Senate. I think he was the lone person. Why the major parties do the way they do? Well, they completely lack courage. They lack leadership. They have no desire to lead, and they're completely bound into a deregulatory paradigm which will kill us all. I mean, that's their political ideology, and their vote needs to fall further.
Yeah, and I guess there is a lot of focus on the cost of living, but a 30% drop in crop yields. I think if your food's expensive now, it's going to be a lot more expensive with those sort of consequences.
Yeah, I mean, I think one of the things that people haven't quite twigged onto yet is how much climate change is a driver of the cost of living. I mean, I've said to various politicians I've met in the last year, I said, this cost of living thing is not going to go away. I mean, there's a thing called food inflation. And we can see it that crops and supplies, I mean, and for various reasons, I mean, there's now a squeeze on eggs in America because of bird flu. I mean, constantly rising food prices, driven partly by the increasingly severe climate crisis, will become a feature of our time. That's one of the immediate economic consequences.
And just a real quick answer for Lena was asking directly, have you actually sent this to to Peter Dutton or Albo or band?
Yes, yeah, yes, we have. And for people who do these things, amongst the ministers, there's this sort of just this awkward embarrassment.
Yeah, we'll get back on the politics in a moment, David. But Jenny Goldie asks an interesting question, and this did cross my mind when reading the report: is where on earth are all the climate refugees going to go?
Well, I mean, this is the issue is very politically fraught because refugees and migration is a very fraught issue. I mean, one of the great ironies is that the Syrian civil war had its antecedents in an epochal drought in Syria that displaced a lot of people from the country into the city, and it led to rising housing and food costs and became one of the triggers for the Syrian civil war. There were some other things, a nasty regime and rising fuel prices that ended up displacing half of the Syrian population. 6 million people internally, and that's another 6 million people externally into neighboring countries, but also into Western Europe. And it was that forced migration of people out of Syria for a crisis that had climate origins that became one of the drivers of Brexit, and one of the really touchy issues in the EU. So we can see already in the past how climate change driving population displacement is a really tricky political issue. And I mean, if you look at that map, that red area, the part of Asia that become unlivable, and we were talking about perhaps half of the world's population. I mean, my simple proposition is we've got to create the conditions where they can stay where they are. We actually have to cool the planet and make it possible to live there, because I can't see a stable, just, and peaceful transition to a situation where half the world's population has to shift quickly.
Yeah, and I might rethink my plans to invest in Fisherman's Bend as well, to make light of it. But it seems absurd that hasn't been examined before going ahead.
Oh, by the way, there's supposed to be a defence facility there as well as a university.
Okay, good. Just moving on to a little bit more about the science, James Whelan was hoping you could speak a little more about net zero versus zero emissions as policy objectives, and I know that the report did touch on this.
I was really taken by a really good English climate researcher called Professor Kevin Anderson, who said you have to understand that net zero is a misspelling. It's actually not zero. And I think that's really important. I mean, the proposition of net zero, which comes out of some really unreliable models, is that somebody can keep on polluting, putting greenhouse gases in the atmosphere, if somebody else is drawing them out of the atmosphere. So the oil company, can keep on selling oil because somebody else is growing some trees that will draw some CO2 down. That's the net business. In fact, it's a lot worse than that, because now there are net deals where people can keep on polluting if they stop somebody else from cutting a rainforest down. So you're actually not doing any drawdown, you're just stopping this thing getting worse. And this is like, the Catholic Church in the Middle Ages selling indulgences. You got a lot of money, you behave badly, and then you fork out some money, and you're forgiven for your sins. I mean, that's what carbon offsets. That's what net zero is. Net zero is a plan to keep on polluting. So if you look at something like the scenarios which were done a few years ago by a thing called the Network for Greening the Financial System, which is a network of world central banks, they had a net zero 2050 scenario where fossil fuel production was half of what it is now. So there was no plan to cut out fossil fuels. They were going to reduce it to some extent and then produce these bodgy systems. I mean, the classic example being carbon capture and storage. for which literally billions have been put in with no practical result, a sort of a cargo cult to defer action by saying there's a techno fix down the path. So net zero is our enemy. It is not zero. It is an excuse for delay. It is a way of selling indulgences to carbon polluters.
David, your report indicates that the AMOC and shutdown would likely increase warming and flooding. Is there a body of research that examines the potential impacts of that shutdown on Australia and New Zealand in terms of temperature projections?
Not I've looked at in detail. I mean, obviously that circulatory system, while it moves water, warm water from the Caribbean up to the north coast of America into Western Europe, is also part of a global circulatory system. I mean, the AMOC connects to the Southern Ocean circulation, so it's going to move heat and weather patterns around the world. And I just know that the models show that Australia is likely to get a bit more rain. I mean, in general terms, because of climate change, southern Australia is drying. It is already drying. I mean, southwestern WA and southeastern Australia is drying. The amount of land that can be reliably used for wheat production, reliable means I think more than 6 good crops in 10 years. The amount of reliable land has already halved in the last 20 years. So southeastern and southwestern Australia is already drying. The opposite is happening in the north. So this would bring a bit more moisture back in, but I don't know what the overall balance is.
Yeah, I've got relatives in South Australia, and I can tell you right now they're cooking. So
yeah.
Graham McClay asks, he says, thank you, David. So thanks, David. It's good to get some encouragement as you're going, but also a simple question, perhaps, is there a place for geoengineering?
Well, I mean, geoengineering is a broad term that is conscious human intervention in the climate system. And I would argue that for the last 100 odd years, since early researchers demonstrated the greenhouse effect, I mean, for more than 100 years, since the late 19th century, we have known that burning coal was warming the atmosphere. So I would say we have been consciously geoengineering the planet for several hundred years, particularly in the last century. So it's not a new thing. That is what we have done. When I talked about climate interventions, I think that strategically it is too hot. I mean, the fact is that in climate history, the sort of temperature we're at now, where we're heading about 1.5, 2 degrees and heading towards 450 parts per million, in past climates, it's never been a point of system stability. And this is because all systems become stable at certain levels, and in between they're unstable. So there has been, in past climates, a point of stability at about 280 parts per million, which is where we were before we started burning fossil fuels. And there's another point of stability at 3+ degrees. So where we are now is not a point of stability, and where we are going to go higher, and it will not be livable. So we have to go lower. We have to get carbon dioxide out of the atmosphere by whatever means we can. I mean, whether that's natural systems in the first place, making them more resilient, getting more carbon into soil, stop forests going up, whatever. If there are machines that can do it, that work and are efficient, good luck. The research is not there yet, but I mean, I think we have to throw everything we get at this. But the problem is that drawdown is a slow process, and we are going to be in a danger zone where ice sheets are still going to melt for decades before those things, even if they applied rapidly, would come in. So do we replace some of those sulfates which we've lost in the higher atmosphere, what's called solar radiation management, to bring the temperature down? I mean, that's a debate. Is it proven? Well, yes and no. There's a lot of literature on it. It's highly contested. People think if you'll do it, it'll be an excuse not to continue emissions. But to my mind, if we don't get the planet to be cooler than it is now, the sorts of large climate systems like the ice sheets, which are in transition, will dump enough ice to put the sea level up by several meters this century. And when that happens, most of the world's cities, which are on coastlines, whether it's New York or London or Lagos or Shanghai or Manila or Jakarta, and a bit of Melbourne, as we saw in the slides, will simply be unlivable, and that is collapse time.
So Peter Bolton's asked the same question. You can't give us a simple yes or no that geoengineering is going
Well, I
to
mean,
be.
I think I don't think it's that I mean, the people are looking at marine cloud brightening, for which there's some good news, which is sort of a regional thing, whether that would help the Great Barrier Reef. There's other people looking at mechanical ways of trying to stop the ice sheets melting by putting sort of engineering under them to stop the ice sheets sliding off the rock. I mean, a lot of things are being tried. I just think we need, look, I know it's a really poor analogy, but at a time of war, governments tend to go into parallel research and development. You research everything that might be of help to see what works. And I think because getting it to zero is simply not enough to stop the system collapse, we really need to put a major effort into researching whether any of these things are feasible. Look, I think the other thing, and there's a very wise American scientist called Mike McCracken, and people can find his work, who worked for the US government, and he says the thing with these climate interventions, if because of uncertainty you wait too long, delay too long, then it will get so hot that they won't work. Because people are saying, oh, we're not sure whether they'll work, we really shouldn't do it at all. He's saying, if you delay too long, it won't work, and then you wish that you'd acted earlier. And I think that's a really important issue that isn't talked about much.
And just while we're here, thank you everyone for all your questions. I hope we can get to most of them, but we do have a real inundation, so to speak, of questions. So we're getting through them through the variety as much as we can. Bill asks, what are the implications for continuing ocean acidification? Will it crash ocean biodiversity and food supply?
The answer is yes.
There you go. Simple yes or no answer.
And I mean, there are signs of that already. I mean, we're parts of the ocean becoming a toxic and simply not. Yes, it will crash the ocean system. And I mean, that's one of the things about coral reefs as well, because we know that effectively going back, say, 50 years, more than 3/4 of the barrier reef has been lost. But it's not in danger, according to the World Heritage people, which is just weird. But in Asia, there are 1 million people who directly or indirectly rely on coral reefs for their livelihoods. Because coral reefs not only provide food and livelihood, they also provide a shelter against onshore destruction. I mean, they're a really good barrier. And already those fish stocks are going down. I mean, perhaps one of the things that has been talked about for a long time is that with warmer oceans, all sorts of things are going to be under pressure, including algae. In part because a hot layer can exist, can form on the top of the ocean that doesn't mix well with the ocean underneath. So there isn't the overturning through the ocean column. And this comes back to the sulfate question we're talking about. Algae en masse produce a thing called DMS, dimethyl sulfide, which helps with cloud formation. So if you really hammer the global algae mass, then you'll get less clouds and more heat and more warming. So yes, in all sorts of ways. I mean, when we talk about cascading and systemic effects, the ocean is really at the center of that. I mean, not only the circulation, but for these sorts of reasons.
David, Anonymous writes, who are the most reputable sources for accurate climate change and sustainability related information? Obviously, there's a lot of noise and a lot of detractors. So,
look, there are some people who are really outstanding and really good. I mean, one of the best is a guy called Stefan Rahmstorf, Stefan Rahmstorf. He's an oceanographer in Germany. He's perhaps the world's leading expert on the AMOC, on the Atlantic circulation, but other things as well. he's just joined up with Sir David King. His commentary is really spot on. There's a group in England of scientists set up by Sir David King, the former UK chief scientist who I mentioned, called the Climate Crisis Advisory Group, who have a really good website with really good stuff on it. Um, uh, Look, I would say this is slightly lazy. Just flick through Collision Course and have a look at the sort of scientists that I've quoted. I mean, today, Johann Rockström, the head of the Potsdam Institute in Germany, who's really good. Catherine Hayhoe from the United States. I mean, if people are referenced in Collision Course, they're probably the goodies. And they are being outspoken, and they are deeply worried, and they're frustrated.
And it is interesting when you see people with such high regard, and typically, many scientists are quite conservative, but they are not being, they're not holding back in what they're saying.
And look, sorry to interrupt. I would say if anybody follows the conversation, there's a younger climate scientist at Melbourne University called Andrew King who writes regularly for the conversation, and his stuff I think is really good and really on the ball, and he's really been pretty honest about what's going on. He's had a couple of pieces in the last week or 10 days, and I agreed with everything he said in both of them.
David, we have talked about some of the interventions that are obviously still not proven per se, but can you talk more about safe and measurable climate interventions that we need in future, or that we know are the most promising?
Well, obviously the first thing in drawdown is that we know drawdown is getting carbon back into out of the atmosphere and back into the systems where it came from. I mean, obviously a lot of it came from coal, but a lot of it is being lost due to degraded wetlands, due to loss of rainforest, and so on. I think those big fires in Canada, was it last year, the year before, produced emissions that were twice Canada's national average. So some of our large natural carbon stores are actually turning into sources. So I would say that the first thing is to try and restore the natural systems that hold carbon. That's proven that's reliable. I mean, all sorts of people. I mean, there's a whole area called blue carbon, and looking at the capacity to build kelp farms and all sorts of things to increase the capacity of oceans and forest. We know that soil can hold, if it's properly managed, soil can hold a lot more carbon than it is now. I mean, this is not rocket science. These are things that all could be done. They take money, but so I would say that's the first and biggest thing. And those stores of carbon should not be used as offsets for net zero. They should actually be used to help draw CO2 out of the atmosphere. I mean, there are many other things. I mean, there's a thing called rock weathering, where certain sort of rocks, and this has happened in the past over very long millions of years, certain rocks that will naturally break down through storms and rain and so on absorb CO2. So can you get those rocks, grind them up, spread them out, and do what's called enhanced weathering? I mean, there are we at Breakthrough have on the blackboard to do a whole report on these issues about them. So they're the ones that I think are natural, proven, and safe. And the Climate Crisis Advisory Group have got a whole report on that. Then there's some more speculative and difficult ones about whether we can stop ice sheets melting and glaciers sliding into the sea. They're more difficult, but as I said, I think we've got to put money into the things that are proven now and research the things that aren't.
Thank you again, everyone who's asking questions, and for the vast variety of questions. We'll go on a different tact now. And Tim asks, our governments should understand the huge risks we're exposed to, but they refuse to act. David, what are your views on taking legal action against governments?
Anything and everything. I mean, some people know this story, but a group was formed a few years ago called the Australian Security Leaders Climate Group, led by Admiral Chris Barrier, former head of the Department of head of the military, chief military officer. And they proposed before the 2022 election to both parties that both parties should conduct a climate and security risk assessment. And that is an honest, assessment of what the climate-related security risks or the security-related climate risks, because it goes both ways, were to Australia. And I mean, the Albanese government said, yes, that's a good idea. We will commission a climate security risk assessment, which they did when they got into government. It was done by the Office of National Intelligence, which was actually a good idea because it was done by some people who were actually competent in the field, and there was no interdepartmental squabbling. That report was given to the government at the end of 2022 and has not been seen since. So this was, and as I understand it, and I've written a bit about it, and it's on the Breakthrough website, a really honest assessment of the risks. And it would be not dissimilar from what I talked about tonight. It would have said that states are going to collapse. States will drown. There will be large-scale people displacement. There will be a chronic water crisis in Asia. The most critical is South Asia, a combination of India with heat and lack of water, and Pakistan, which has got all sorts of intersecting problems. This was said to the government, and the National Security Committee of Government, Committee of Cabinet saw it, and they decided never to release it. And the reason was quite simple. What it said would have made absurd what the government was doing, increasing gas and coal production. So this is the problem. They know, and then they hide it. That they know and don't know. And I think, as I've said many times, there seems to be almost this assumption that you can get the climate solutions without ever naming the problem. And what we've tried to do tonight in 10 fairly crisp points is name the problem. I mean, the fact is that in this country, there's never been a serious, sustained public discussion of the things we talked about tonight. In the media, amongst the political class, in universities, about this collision course humanity is on. I mean, it is simply not there. And it just seems mad that, this is the greatest threat. I mean, the security leaders say climate is the greatest threat, not China. China's not the problem. In fact, they're producing 2/3 of the world's renewable technology. They're probably the answer. But this idea that we can't talk about this threat, it's like, it'd be like COVID coming along and now he's allowed to say COVID's in the hospital. I mean, that's where we are. So, I mean, it's really important for all those independents and teals and greens and so on to make this a public conversation, because there's a reason why the Albanese government suppressed that intelligence report, because it would open a can of worms, and that can really needs to be opened.
Do, that really goes to a couple of questions we have. One from Sonia. She's obviously pretty disturbed by what she's heard tonight. How can we change people's hearts and minds in the face of declining education and increasing methods of mass distraction? And also this goes to Janine's questions as well. How do we work against the propaganda? Because facts on their own don't seem to be cutting through.
And there is obviously a problem with big tech and people like Musk and others, the surveillance of people, the use of algorithms to increase social discord, for the mass spread of dis and misinformation. I mean, this is a serious structural problem which had its consequences in the US election last year, and I don't have any easy answers to that, except to say there was an opportunity for governments to regulate social media and big tech, and they didn't, and it is absolutely necessary to do so. I mean, and it is very simple. If a newspaper or the television station you work for or others say something which is untrue or libelous, they get sued because they're responsible. With big tech and digital platforms, they allowed or managed to get governments to say, oh no, you're not responsible for what's said on your platform. You're just the message board. And that's the problem. And if all of those networks and social platforms were legally responsible for the content that they carried, a lot of this problem would go away. So I think that's way outside my area of expertise, but I mean, I think that's one issue. I mean, I think it's really important to engage in people one-to-one and face-to-face. conversations in community and giving people a voice and educating them and deliberative democracy and all those sort of things can produce amazing results.
Right, David. I think we're already running over time. So, and again, apologies to all those people who've asked amazing questions and really deep questions that we haven't been able to get to. But Nick is the final question comes from Nick because it's quite. I think it comes to the heart of what this is about. Obviously, we can talk about governments and what needs to be done structurally, but so we can all try and sleep tonight. Is there something we can do as individuals to enact change beside advocacy? You know, what can we do, David?
Well, I don't know how many people sort of go to family dinner or Christmas party or whatever and find that there's now, there used to be three things you couldn't talk about at these things, wasn't it? Uh, God and sex and something else. But I mean, I go to events and everybody deliberately doesn't talk about climate change ever. But they all talk about the next trip and where they're going and, how they went to Fiji with 50 people for somebody's wedding and so on. I mean, I think the conversation, and they're good. I know there's another session during the festival on this question. I think conversations wherever you are, whoever you are with, is the starting point, even though it's a bit uncomfortable sometimes for the others, if not for you.
Well, this conversation has been uncomfortable in parts, David, just facing the reality of the predictions and I guess the reality of what we're seeing, which is 1.5 is kind of almost in past tense.
There.
Yeah. So unfortunately, that is all we have time for. And I want to extend my huge thanks to you, David. It's a big effort to sit there online and go through. And also congratulations on the report. It's a great deal of work. And I encourage anyone who hasn't yet downloaded it and read it start to finish to go to breakthroughonline.org.au. Please feel free to share the report far and wide. And remember, the conversation, as David was just saying, doesn't end here. Let's continue to work together to advance this very urgent global cause. Can I please extend a thanks to a technician and a very busy person behind the scenes, our Managing Director of Breakthrough, Luke Taylor. So thank you very much for your help, Luke, in bringing this together. Again, thank you all for joining us. I know your time's precious, and until next time, please stay safe and stay informed. Good night.